Hello, welcome to the 8-4 notes, which are going to be properties of rhombuses, rectangles, and squares. So the first thing we're going to do is review the definitions and properties of a parallelogram, the 6 that we've been talking about for a few days now. Let me try to zoom in here. Alright, so the first one that I always write is the definition of a parallelogram, and that is that it's a quadrilateral, but I don't write that. I just say it has both pairs of opposite sides are parallel. All right, the second one, and the order doesn't matter, but both pairs of opposite sides are congruent. Now, I don't know, some people know this abbreviated way to not have to rewrite something that you just wrote above, and that's like putting quotations below it. So that would imply both pairs of opposite sides are congruent. And look how much time I saved all of us not having to write all that. All right, next one. Both pairs of opposite angles are congruent. And if you want to write all the words, sure, go for it. I don't like to. Consecutive angles are supplementary. And so again, that means angles next to each other, not across from each other like opposite angles. It's the ones right next to each other. The diagonals bisect. And the last one is not technically a property. I don't like calling it a property or a definition. So like I tell my students, put this little squiggly line and then write it, because this is really just a way to prove that it's a parallelogram. That's one pair of opposite sides is both parallel and congruent. So you wouldn't have to do both pairs of opposite sides, just the one. All right, so now we're going to get into the more specialized types of parallelograms. The first one is a rhombus. So the first property of a rhombus is it is 1 through 6 from above. It has all those properties, just like a parallelogram has the properties of a quadrilateral, meaning 4 sides, angles add up to 360. A rhombus has all 6 from above. Now here's what makes a rhombus special. It has all 4 sides that are congruent. So all 4 sides are congruent. Okay, so that's not a square. A quadrilateral with 4 congruent sides is a rhombus. All right, the next one is the diagonals are perpendicular. And don't forget the symbol for perpendicular, so we don't have to write that long word. We write it upside down, capital T. And then the last one is the diagonals bisect opposite angles. All right, so I'm going to draw a rhombus for us. I'm really bad at drawing rhombuses, especially without like a ruler. Yikes. Okay, so all 4 sides are congruent. That is right there. Diagonals are perpendicular, and this is when I know I drew a bad rhombus, because I can never make these diagonals exactly perpendicular, but that's what that would be. Okay, the diagonals, they still bisect each other. Okay, so like this piece is still the top one here. Here is congruent to this one, and then the other 2 are also bisected, split in half. Here's the part that I always have like a hard time explaining or writing the definition. The diagonals bisect the opposite angles. So what that means is this angle got bisected. So each piece is equal, and because opposite angles are congruent, those are the same. And then this angle and this angle get bisected. So then these are congruent to those. And those are the properties of a rhombus. Okay, next, a rectangle. All right, so just like a rhombus, a rectangle is a parallelogram, so it's going to have numbers 1 through 6 from above. Okay, number 1 through 6 from parallelogram or from above. Those all trickle down to the rhombus. And now here's the new one. A definition of a rectangle is it's a parallelogram that has 4 congruent angles. So they have to be 90 degrees. And then the diagonals are congruent. All right, so I'm going to go and try to draw one. This is already looking much better than my rhombus, So now 4 congruent angles means it's going to have 4 right angles because it's 360 divided by 4. And the diagonals are congruent. So from a parallelogram, we know that they're bisected. So that diagonal gets split in half. Now with the other diagonal being congruent, we could do a tick mark and a tick mark there. Here's what's awesome about, in my opinion, what's cool about rectangles is this side's congruent to this side because it's a parallelogram. This side's congruent to this side because it's a parallelogram. So then what we have is these two triangles, this top and bottom one, are isosceles triangles, and they're congruent to each other. And then this triangle is congruent to that triangle. And so with a rectangle, if I gave you just one little angle here, you can find every single angle of every single triangle that was formed in here. And I think we'll have an example like that coming up. All right, the last one that we're going to talk about today is a square. And a square has all 4 angles and all 4 sides are congruent, has all 6 from above, number 1 through 6 from above. And then because a square comes from a rectangle and rhombus, it is a rectangle and a rhombus, it has all 4 sides congruent, or I should say all 4 sides and angles are congruent. So if you remember from, why did I write the word congruent? Darn it. If you remember from 8.1, we talked about regular polygons. So a square is a regular quadrilateral. 4 congruent angles, 4 congruent sides, and then the diagonals, it has special properties. From the rhombus, it gets the fact that the diagonals are perpendicular, and then from the rectangle, it gets that the diagonals are congruent. So we have all these little right triangles that are formed. We have little isosceles triangles that are formed. They're all congruent. All the isosceles are congruent to each other. We get a 45, 45, 90 triangle every single time. That's going to come into play because when you draw that diagonal, you split that, the legs are congruent here, so that means it's a 45, 45, 90. So these shapes lend themselves very heavily to a lot of trig from last chapter. So if you never learned the trig from last chapter, you better learn it now because it's coming back and it's going to come back in future chapters as well. All right, let's take a look at the first example here. It says we have rhombus QRST. Decide whether each statement is always, sometimes, or never true. Angle Q congruent to angle S and angle Q congruent to angle R. Okay, well, I need to, for myself, draw these shapes. I can't just go based on trying to picture it. So I'm just going to sketch myself a quick rhombus. Okay, and it's QRST. Here's what I know about a rhombus. All of its sides are congruent, diagonals bisected, what have you. All right, Q congruent to S. Well, looking at this picture, those angles are opposite from each other. This is always going to be true because it gets that property from a parallelogram. So any of those 6 properties of a parallelogram will always be true for a rhombus. They will always be true for a rectangle, and they will always be true for a square. So this one's for sure always. Now here's the tricky one. Q congruent to R. If this was a square, then our answer would be always, because the angles of a square are always congruent. But this is a rhombus, so they don't have to be congruent to each other. They could be, but they don't have to be. So this would be true if that rhombus was a square. Okay, so this one's going to be sometimes. I know that might be confusing. These always, sometimes, never questions are the ones that kids typically struggle with the most in this chapter. Like, I don't get it. So just to reiterate, if you looked at that quadrilateral tree that you got, a quadrilateral is all of them. A parallelogram is a square is a parallelogram. A rectangle is a parallelogram. A rhombus is a parallelogram because they all fall under that parallelogram tree. A square is a rhombus and a square is a rectangle for sure because they come together and they form this square. Now, a rectangle is sometimes a square. It could be. Doesn't have to be. It sometimes is, whereas a square is always a rectangle. And we'll practice that more in class and outside of class too and in your classwork to get you kind of comfortable with those ideas. All right, example 2, a quadrilateral has 4 congruent sides and 4 congruent angles. Classify this quadrilateral. The only one that has that happening for itself is the good old square. So this would be a square that has 4 congruent angles and 4 congruent sides. All right, example number 3. Name all quadrilaterals for which the following statements are true. Answers: parallelogram, rectangle, rhombus, square. The diagonals are congruent. All right, so when we think about our tree, our quadrilateral tree, that starts at the rectangle, okay? That is one of the properties that a rectangle has. So diagonals congruent for sure is a rectangle. Now, if you were paying attention earlier when I was talking, a square is a rectangle, so it's going to have the properties for sure. Some people might be wondering, why doesn't a parallelogram have that? Because if you look at the properties of a parallelogram, that's not there. Diagonals congruent doesn't happen until a rectangle. So a rectangle will have it, and anything underneath a rectangle will have it if you're looking at your quad sheet. A rhombus is not connected to a rectangle, so it does not have that. All right, next one is no acute angles. So I'm thinking of a parallelogram. Could we have angles that are acute, meaning less than 90 degrees? Yes, we could. In a rectangle, can we have acute angles? No, because all the angles are 90 degrees. A rectangle is not going to have any acute angles. So therefore, because a rectangle has it, a square also has 4 90-degree angles, so a square. In a rhombus, can you have a acute angle? Absolutely. There's nothing that says that you can't. So here we have just a rectangle and a square. Example 4. Consider the rhombus shown. Calculate the following. All right. Well, I like to start, first of all, with anything that I could possibly fill in just from knowledge that I have. So here I have that this little segment TR is 6. That would make TP equal to 6. That is not a property that just a rhombus has. It gets that property from a parallelogram. Then I know, because it's a rhombus, all of its sides are congruent to each other. All right, next thing I know is that the angles get bisected. So right here, I know if this angle's 30, this one has to be 30 as well up here. Okay, that one's also 30 degrees. And likewise, opposite angles are congruent because of a parallelogram, so each of those is also 30. Last thing I know is that the diagonals of a rhombus are perpendicular. So make sure that you always have your quadrilateral sheet with all those properties written, because there's a lot to remember for every single one of these shapes, and it does get confusing. So if you could just mark everything you know to be true, then it's going to help you hopefully a lot when solving problems like this. Okay. First thing they asked me for is the measure of angle QPR. Well, notice I already wrote that in because QPR, remember, order matters. So QPR is that angle right there. So how big is it? We already wrote that in. It is 30 degrees. Right, the measure of angle QTP. We already wrote that in as well, 90 degrees. Nice. Next, the measure of RP. We know each little diagonal piece got bisected. Each was 6, so it is 12. And finally, QT. We are looking for this segment right there, QT. If I focus on this triangle, I'm going to replicate it. I'm going to draw it right here. Okay, where this is my right angle. This is Q. This is T. This is P. So I know this angle is 30, from P to T is 6, and from Q to T is X. Now, I notice it's a 30, 60, 90. That's not always going to happen, but because it is a 30, 60, 90, I have the long leg, so I can use that. And so then I know this is L, and this is L root 3. All right, solving for L, using this formula and solving for L, I would have 6 equals L root 3. So L would be 6 divided by the square root of 3, and I could leave that as an answer, or I could rationalize it. So that's it, because that's what X is. Or, depending on how your teacher wants you to solve this, you could also do trig. All right, so I'm going to redraw that triangle again, just real quick. This is x, this is 6, this is 30. Which trig function would I use? Well, I'm looking for the opposite. I have the adjacent. I would use tangent. Tangent of 30 is equal to x over 6. So x is going to equal, if I put that over 1 and cross multiply, 6 times the tangent of 30. And I will use my calculator to get that. 6 times the tangent of 30 is approximately 3.46. All right, which is 6 divided by the square root of 3. Ask your teachers tomorrow how they want you to show that answer, if exact, or if it has to be, or if it could be an approximation. All right, last one here. Consider the square shown. Calculate the following. Well, it's a square, so each of the 4 sides is congruent, or are congruent, I should say. So blah, blah, blah. 1 tick mark for each. The diagonal gets bisected, and the diagonals are congruent. And then they are also perpendicular to each other because a square gets that from, the rhombus. Okay. Each angle was 90, so just realize in a square, always you're going to have a bunch of little 45, 45, 90 triangles. Those are all congruent to each other. All these angles are all 45, 45, 45, 45. All right, find the measure of angle GHF. GHF is right here, so that angle is 90 degrees because the diagonals bisect each other. DGH. We just said all of those little angles are 45 degrees. The length of HF, we already wrote that in as well. It's 5. And then the length of DE, we did not write in. So that is this side. Each side of the triangle. Let's call that X. And my first instinct is that's a special right triangle. It's a 45, 45, 90. So this would equal the leg times the square root of 2. That would give me the answer 5 square roots of 2 for that length. Okay, that is not the only way to do it. I could do Pythagorean theorem. Focusing on this little right triangle, I could write 5 squared plus 5 squared equals x squared. I would get 25 plus 25 equals x squared. So 50 equals x squared. Square root both sides. X is going to equal plus or minus, but we don't want the negative. Square root of 50. That simplifies because there's a 25 perfect square in there. Factor of 25, which is a perfect square. It's 5 square roots of 2. All right, the last way you could do it is possibly using trig, but I would never recommend that way. It's a lot easier just to do special right triangles or trig. Okay, that's it for these notes. We'll be practicing this. There's a lot of properties there. I know that. I know it's very confusing when to use which one. It's just something you have to practice and get better and better as you do practice it. All right, thank you so much for watching and have a great day.